that's kind of what these percentages are down here, or average is good. I think averaging is an extraordinarily important tool. We did it in 244 with some data we collected. Very, very good. Wouldn't that just be reporting back on the data, though? Kinda, yeah. Unless you took the average and did what with it. This is an interesting thing, you know. Oh, good! More averaging. Good. Oh, you're one step ahead of us, brother. This is good. This is a couple steps ahead. This is good. But again, that's reporting back on the data. Unless you took those means, those medians, those modes, and did what with them? What? Say that again. Is that Sean? Let me hear from you again. Go ahead, brother.
Hypothesize.
What do you mean by that?
You can make extrapolations on what could happen.
Wow, I don't know what you're talking about. I'm looking at electoral map. How could I possibly hypothesize about what's going to happen in, oh, I don't know, 2016? If you take the data that's been collected and make a report, mean, median, mode, graph, some kind of graph, and then don't stop there, but then take that information and try to predict something that's going to happen later, that's where you step over the bound of descriptive. It's not a bad thing, it's just what you can do with it. And it becomes what's called, it becomes what's called statistical inference. You hypothesize about your data and say, huh, if this data is indicative of what's actually going on, I bet, yeah, and yeah, we fill it as we go. It's mostly 244. Yes. So here's the deal. I haven't really defined it very well up here, and it's intentional because I don't think there are super perfect definitions. We'll define it in context. So what you do is you make a prediction. I use the word prediction versus hypothesis. That's okay, Sean. Same exact idea. You've got an idea you want to hold up. And the thing is, the only way you can do that is drawing a sample from what is called a population. Here's the difference. The election map was a little bit of a bastard move because essentially they collected every single vote from that election. And they put it all into a big spreadsheet and they graphed the results. That essentially has to happen. It's called a census. Every 10 years, the United States Census Bureau has to go around and try to count every single American. Even they are beginning to accept that that's an impossible feat. I mean, it was great when, like, 1771, when there were, like, 20 Americans and 20 horses, and it was like, yo, Tom, you were around? Yeah, check. Now there's, like, 310 million people. You gotta count them all, how many cars they have, how many pets they have. It's becoming ridiculous. So it's very hard to get what's called a census from a population. A population is some entity that you want to study, right? What's a very popular population in an election year? What is every Gallup poll about in an election year? Registered voters. How many of them are there? 10? Million, maybe? 10 million, 20 million, 50 million, I'm guessing. I'm throwing numbers out there. Now, not who actually votes, which is like 56 people. But like 50 million registered voters or something like that. Many million registered voters, correct? So Gallup always wants to know what, I mentioned Gallup, Quinnipiac, Rasmussen, Fox News, CNN, Time, Money. They all want to know what the voters are going to do. And you probably already started hearing about who's going to vote for Hillary, who's going to vote for whoever who's the GOP putting up for president.
Unfortunately, we're probably going to have another Clinton versus Bush.
Oh, really?
That's what it looks like.
Oh, literally Clinton. I got you. Is Bush actually running?
Well, you got Jeb.
Oh, he has his hat in the ring, maybe?
No, I thought Jeb Bush wasn't
running.
running.
I thought that was next.
I'm sorry I asked the question. I don't want to get son of a...
No, I know him. I can hash it out with him later.
That's okay. Oh, God, here we go. That wasn't a threat, YouTube world. That wasn't... She put the pencil down. So the idea is, though, we want to know what's going to happen. So they start doing these preview polls. Even during an election, they do what are called exit polls, where they grab people coming out, they survey that data, and then they predict, based on that data, what's going to happen at the end of the night. Those are terrible ideas, FYI, by the way. Those are absolutely awful ideas. I hope they stop doing those, too. But the idea is, sometimes it just becomes too prohibitive to actually do what's called a census, which is counting everybody. So you don't do a census. You take what's called a random sample. A random sample. More on that momentarily. I know I didn't define it. But your sample, hopefully, will give you a good look at your population. In other words, your sample is a little tiny mini population. Hopefully, if you drew it well. And if you draw it well, statistics says it will be. We'll get more to that throughout the course of this entire course. So, rather than define those, what I've done is I've had you guys to a little bit of a study I put up from 2010 Study claims caffeine addicts get no jolt from morning coffee. Study claims. That's the first thing your ears perk up. Study claims. Really? What does that study claim? I want to hear this. I want to hear this. So psychiatrists are poking holes in a study done by British scientists claiming that coffee drinkers don't get any true wake-me-up perks from their morning brew. I've often heard about this. People become desensitized to caffeine, and therefore they have to drink more and more of it, and then pretty soon it has no effect. I have no idea if it's true or not. Caffeine sends me over the edge. So the idea, though, is I don't care about that. Who's the population we're interested in this? Right, caffeine addicts, they're calling it. I think you guys are correct. Coffee drinkers is the actual population. Caffeine addicts. Coffee drinkers. That's the other reason you want to read past the headline, too. Very often the headlines are shock value headlines, right? Congress is less popular than syphilis. That's the headline. That's the headline that was up about a year and a half ago. That's because Congress's approval rating was 9%, syphilis infection rate is 10%. Boom! 9 is less than 10, less popular. So just read past the headline. So the population is coffee drinkers. So can you see why you couldn't count every single coffee drinker? How many of them are there?
A lot.
How many got in this room? There we go. That's like 2/3 of the room, right? Hey, beautiful. So extrapolate that out. Let's pretend 2/3 of the country drinks coffee, or 2/3 of the college-age population drinks coffee. That's a lot of million people, yeah? So you don't count them all. You don't measure them all. What do? You take a small sample of them. In this case, it was 379 adults who were coffee drinkers. They gave up caffeine for 16 hours. And they did all kinds of measurements on them. I don't care what the measurements were. The key is that was your sample drawn right there, the 379 adults.
Isn't
Okay?
very much.
Say that again?
It's not very much.
A very common complaint, Sarah, is that statistical power is lacking in some of these studies, and power is basically directly correlated to your sample size. Believe it or not, you can do wonderful statistics on very few data points. Give you a precursor. Remember the BP Deepwater Horizon explosion? About 2010 as well. I remember when it happened. I was sickened by it. And then I saw the Coast Guard got on the news that night and said, we're losing about 1,000 barrels of crude a day into the Gulf. And I remember seeing the YouTube video of the oil pumping out of that pipe going, did he say 1,000 per day or 1,000 per hour? Or 1,000 per minute? And I went back and watched it. It was 1,000 per day. I'm like, that is way more than 1,000 per day. So what I was able to do was get 6 data points from that YouTube video and approximate some flow rates.
Oh, wow.
From those 6 data points, I got almost the exact estimate BP did 2 months later, and finally admitted to how much oil came out. So you don't need a lot of data as long as your data is good. As long as your data is good. Yeah. More crap data is actually worse than less good data. Because more bad data actually, it's almost like using a gun with a highly precise but extraordinarily inaccurate scope. Like, bird, 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 I hit that clock perfectly. Did you see that? Perfect, perfectly. It's great, you hit the clock, you're over the bird though, right? Highly accurate, low precision would be like, bird, 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 and somewhere in there, maybe I hit the bird. I cast the net around the bird, perhaps. So, don't be too swayed by the number 379. I just want you to focus on that's the sample that we're talking about. And here's the deal, that sample is going to have a statistic or more than one statistics associated with it. That's why this course is called Probability and Statistics. You don't actually want to know about the statistic, you want to know about the parameter, which is how the similar measurement is made in the population. So you want to know what percent of Dems are going to vote for Hillary, but you're never going to know exactly what percent of Dems are going to vote for Hillary. You're going to know what percent of Dems in your sample are going to vote for Hillary, and then you make adjustments on that to apply it to your population. More on that after our break to see how we actually do that statistically, because that's important. That's important. The news often gets it wrong, and I want to make sure you guys see how to do it correctly. But I'm starting to sense that we're getting ready to walk around a little bit, get some more oxygen in the room. Yes, Shaw is exactly right. Let's shut this down for a moment. Let me take